This is R.D. Sharma solution, class 11, chapter 28, Introduction to 3D Coordinate Geometry, exercise is 28.2. Now this is question number 1. So there are two parts here. They are exactly same. Find the distance between the following pairs of points. So P is given as 1, -1 and 0. 1, -1, 0. These are the three coordinates x, y, z. Then we have q, 2, 1, 2. What you have to do? You have to use the distance formula. This is x1, y1, z1. This is x2, y2, z2. So x2 minus x1 whole square plus y2 minus y2, 1 minus of minus 1, that is 1 plus 1, 2 and minus 0, 2 minus 0 whole square, and then you have under root. So do you get 3? Second also the same thing, exactly same thing. Now question number 2 is also the same thing. So 2 points are given, -2, 3 and 1. This is first point, and the other point is 2, 1, 2. So -2, 3, 1 and 2, 1, 2. So you have to use the same formula. x1, y1, z1, x2, y2, z2 is given to us. So this is x1 we have. So 2, 1, 2 is x2, y2, z2 and -2, 3, 1. Even if you do x1 minus x2 whole square, y1 minus y2 whole square, or z1 minus z2 whole square, it doesn't matter. Exactly same thing is going to come. This is question number 3. Now there are 3 parts here. One of this part we are going to do. Using distance formula, prove that the following points are collinear. So we have A, B, C. Now if we can show AB plus BC equal to AC, or say AC plus BC equals AB. So for that, what you have to do, you have to take ABC, find out the corresponding distances. So we have 1, 2, 3 pairs. We have 4, -3, -1, 5, -7 and 6 and 3, 1 and -8. So try to find out AB. This is this 5 minus 4 whole square, -7 minus 3, -2 minus 3, that is plus 3 whole square, 6 minus 1 minus 1, that is 7 whole square. And then you have this BC, 3 minus 5 whole square, 1 minus 1 minus 7, that is 8 whole square, -8 minus 6, that is 14, -14 whole square. Now AC. AC is 3 minus 4 whole square, 1 minus 1 minus 3, that is 4 whole square, and then -8 minus 1, that is -8 plus 1 whole square. So this is, if you take AB, it's root 36, and AB, BC, AC. If you add AB and AC, you'll get BC. Root 66, root 66 add, you get 2 root 66. Right? So this is, it's not A, B, C which I am showing. Actually it's AB plus AC is BC. That is A is in between. A is in between. So you have this AB plus AC, or you can say BA plus AC equals BC. Therefore these 3 points are collinear. Collinear means co-linear, on the same line, linear. This is the second part. I hope you'll be able to do this also. And third part also exactly same way you have to do. This is a 4th number question. Determine the points in xy plane, yz plane and zx plane which are equidistant from the points A, B, C. So you are being given point A, which is 1, -1, 0. B is 2, 1, 2. 1, 2. And C point is also given 3, 2 and -1. So we have to find out the points in xy plane. So whatever I am doing for xy plane, exactly same thing you have to do for yz and zx plane. Okay. So xz plane, one point you have to take in xz plane. In xz plane, what do we know? We know that in xy plane, z is 0. This is x, this is y, this is z. So if you are talking about XY plane, that is this plane, Z is 0 here. Z is 0. So how can you have a point X, Y, and of course Z is 0. Any point on XY plane will be some X, some Y, and then 0. Now we have one point A, one point B, one point C. So take this point, assume it to be P. I don't know where it is, but assume it to be P. So X, Y, 0. Now we will take the distance of P from A, P from B, equate it. Then we take distance of P from B and P from C and then equate it. And then we will find out the equation and solve it. So X, Y, 0. This is point P. So first find out the distance P from A. And you know the distance formula by now. We have done it already in the second question. Then you have PA, PB. So you equate PA with PB. PA with PB. Let me just expand it. So when you open this, it will be an equation. I hope this is just a distance formula. I squared it because we don't want the root. And we have a linear equation. Then same point. This is P. So now take PB and take PC. PB and PC. So now equate PB with PC. It is distance of X, Y, 0 from 2, 1, 2. And distance of X, Y, 0 from 3, 2, minus 1. Means the PB which we have taken in the first part, same thing you take in the second part. Right? So same thing you have to do. Again, PB square, PC square we are doing because we don't want the under root. So just adjust it and you will have two equations. You know how to solve the straight line 2 equation. These are simply the straight line. And what do you get? Just take this in the second equation, x as pi by 2 minus 1, put it in the first equation. Solve it, you will get y as 1. And when you put y as 1 in pi by 2 minus 1, the x will be 3 by 2. So x and y you got, z is of course 0. So you have 3 by 2, 1 and 0. Now coming to the YZ plane, again, YZ plane what you have to do? Only x will be 0, y and z will have some value. Same as the previous question we have to do. We have to find out PA, then PB and PC. First take PA and PB. Then take PB and PC. The P is of course 0, YZ. X is 0 here. Now distance of this P from A was what? 1 minus 1, 0. Then we have PB. B was 2, 1, 2. Now the second condition, TC, 3, 2, 1, minus 1. So you have two equation, linear equation. You just have to solve this. X is of course 0, y and z you will get. And what do you get? Here, same thing. You have ZX plane. ZX plane, so y will be 0. So x 0 z. X 0 z. Now this is question number 5. And this is determine the point on z axis which is equidistant from the point 1, 5, 7 and 5, 1, minus 4. So first thing is, this is, you have to find, first let me just tell you that point on z axis will be what? We are not talking about plane, we are talking about an axis. So at z axis, x and y will be 0. On x axis, y z 0. On y axis, zx will be 0. So simply, you have a point like in the previous question. On z axis, it is 0, 0, 0, 0, z. X and y will be 0, 0. Z will be z. So now this, assume it to be point M. It is point M. So we have this A, and then A point is 1, 5, 7, and B point is 5, 1 and minus 4. So what you have to do is AM. Okay, this distance formula you know. Then you have MB. So 0, 5, 0, 1, 2, minus or minus 4 whole square. So distance you know how to find it. Now these distances you have to equate because the AM BM distance is equal. So equate it, square it, directly z will come as 3 by 2. X and y is 0, z is 3 by 2. Now this one is question number 6. So this is find the point on the y-axis which is equidistant from the point 3, 1, 2 and 5, 5, 2. So same thing you have to do here as we have done this one. This on the y-axis x and z will be 0. So 0, y is 0. Same thing you have to do. You have P point, Q point, P is 3, 1, 2, Q is 5, 5, 2. To find out this distance, 3 minus 0, 1 minus 0, 2 minus 0. And this is 5 minus 0, 5 minus y, 2 minus 0 whole square, add and take under root, equate. Y will come as minus 1. This is question number 7. Find the points on z-axis which are at a distance of under root 21 from the point 1 to 3. So z-axis. Now coming on z-axis. Point on z-axis as we just discussed, it will be 0, 0, z. X is 0, y is 0. So on z-axis you have 0, 0, z as some point. It is not necessary you compute z. It means z can be any point. You can assume it to be p. So there is a point 1, 2, 3. The distance between these 2 points is under root 21. So we have 0 minus 1 whole square, 0 minus 2 whole square, z minus 3 whole square under root equals under root 21. So this is the only equation you have to solve. I know you will be able to solve it. There will be 2 z will come because basically z minus 3 whole square will be equal to 16. Z minus 3 equal to plus minus 4, one time take plus, one time take minus, z will be 7, z will be minus 1. So the 2 coordinates you are going to get. 0, 0, 7 and 0, 0, minus 1. 8 octants are there, remember. 8 octants. Now question number 8 it is. Prove that the triangle formed by joining the 3 points whose coordinates are 1, 2, 3, 2, 3, 1, 3, 1, 2 are equilateral triangle. So equilateral triangle. See, equilateral triangle means all the sides has to be equal. So just use the distance formula A, B, find AB, then BC, then AC, and this is 1, 2, 3, this is 2, 3, 1, and this is your 3, 1, 2. So find out the distance, and the distance just take them and see whether they are equal or not. If you find out the distance, it will be equal. So this is under root 6, under root 6, under root 6. So all the 3 sides are equal. That is, this is an equilateral triangle. This is question number 9. Show that the points, these 3 points are given, are the vertices of an isosceles right angle triangle. Isosceles right angle triangle. So isosceles means 2 sides are equal. Right angle triangle means we can use the Pythagoras theorem. One angle is 90 degrees. So we will take again the distance formula here. So we have 3 points. This is A, this is B, and this is C. So A, B, and BC will try to take them, and they will be equal. And then we'll show AB square plus BC square equals AC square. That will prove that to be 90 degree also. Okay. So what we will do? See, first of all, this is 0, 7, 10, and this is minus 1, 6, 6, and third point is minus 4, 9, 6. So distance formula, just use the distance formula. So this distance formula AB and BC, you will see it will be 3 root 2, 3 root 2. Okay, it will be 3 root 2, 3 root 2. So 6 minus 9 whole square, 6 minus 6 whole square, 3 root 2 under root 2. Just take under root. So now we have this one side as 3 root 2, the other side will be also 3 root 2. Now the 2 sides are equal, so isosceles is proved. The right angle triangle, what do we do? 0 minus of minus 4, 7 minus 9, 10 minus 9, 6 whole square. So this square will be 3 root 2 whole square plus 3 root 2 whole square. It should come as 6 square, that is 36. So 6 square, 36 it should come. So if you see 3 root 2, 3 is a 9, 9 to the 18, 18 plus this is also 9 to the 18, 18. So you'll get 36. So 36 equals 36. So these two things are proved. Now the next question is question number 10. Show that the points A, B, C, D are the vertices of a square. So if you can show all the sides as equal, it will be square, and also the diagonals are equal because it may be a rhombus. So if the diagonals are also equal, see here, what we are going to do is, this is the square we are talking about, A, B, C, D, and this is given as 3, 3, 3. B point is XYZ 0, 6, 3. C is 1, 7, 7. D is 4, 4 and 7. So what we have to do? Take the distance. You know how to find out the distance? Distance formula we have already done. So y2 minus y1 whole square, x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 whole square. Add them, take the under root, take the square root. So this you have to apply for each and every vertices. That is AB, 3 root 2 will come. If you see BC, CD, DA, all will be 3 under root 2, right? 3 root 2. So this is this. Now this is a square, but it can be a rhombus also. So in order to confirm that it is a square, we will try to find out the diagonals. And the diagonals, we have this A also, C also. Similarly, for the other diagonal, we have D and B. Both we have. So now just find out the distance with the same way. And we have this 6, 6, 6 as the diameter, this diagonal, and hence this is a square. Now here the question is, prove that the points A, B, C, D taken in order are the vertices of a parallelogram. Also show that ABCD is not a rectangle. So what we will do here is, first parallelogram. We know that the opposite sides are equal. For a parallelogram, the opposite sides are always equal. Though, and they are equal also, they are parallel also. Equal also, opposite side. So we'll take these points A, B, C, D. We'll take the distance AB and DC. That is AB 130, A is 130, B is minus 5, 5, 2, C is minus 9, minus 1, 2, D is minus 3, minus 3, 0. So first, all side, basically you have to find all the side. That is AB and DC has to be equal. Then all the sides, that is when you find BC and AD or DA, this will also be equal. So AB, CD, AB equals to CD. This will come as equal. Similarly, BC and DA or AD, this will be equal. This question we have already seen. Exactly same way you have to find out the distances. The concept I am telling you. So the opposite sides will come equal. That is, it will be a parallelogram. But we have to show that it is not a rectangle. What do we do? If it is a rectangle, we will try to find out the diagonal. The diagonal, if they are not equal, because a rectangle, diagonals are equal. So when we find out AC and DB, you will see that they are not equal. Hence it is confirmed that it is a parallelogram and not a rectangle. It's a parallelogram because of the opposite sides being equal, but because the diagonals are not equal, it's not a rectangle. Question number 12. Number 12. Show that the points A, B, C, D are the vertices of a rhombus. So we have a rhombus here, and rhombus similar to a square. It's basically a diamond shaped figure with all the sides equal. A, B, C, D. All the sides are equal. So AB, so the points are given as A is 1, 3, 4, B is minus 1, 6 and 10, C is minus 7, 4 and 7, and D is minus 5, 1 and 1. Now these distances you have to find out, that is all the sides you have to find out, and you will see all these will come as 7. All will come as 7. All the sides equal. Okay. Then you find out the diagonal. And the diagonals, as I said, because all the sides are equal and the diagonals are not, there are two things. The diagonal bisection and diagonal equality. So you can check that. See, if you find out the sides are equal, it's confirmed. So you don't have to go ahead. I'm just saying that you can go a step ahead and try to find out the distance of the diagonals. And then you see the distance between them. Question number 13 is, prove that the tetrahedron with vertices at the points O, A, B and C is a regular one. So when we say a tetrahedron, that means it has 1, 2, 3. So there are faces here. Means it's not a 2D figure. You have to imagine that this is a 3D figure. 3D figure. Okay. Tetrahedron means it has 4 edges, 4 vertices. And with these 4 vertices says a figure has been drawn. And that is a 3D figure. Tetrahedron. Okay. So what you can do is, you can find out this OA, OB, all the sides actually. All the sides, that is AB, BC, then you have AB, BC, and AC, then OA, OB, OC. So there are 6 edges here. And you have to take the distance of all of these. And you will see that all the sides are going to come as equal. And there are, in the left hand side you see, and the right hand side you see, there are 2 different solutions which I presented. They both are same. Means both are, in a way, they are doing the same thing. But the approach is different. So only thing which you have to do is, either you find OA, OB, OC, if you assume it to be a 2D. OA, OB, OC. And these are equal, that means the face is an equilateral. So you have 3 triangles which are equilateral triangles. So we say the tetrahedron is a regular one. The other one is, you take all the edges I told you. That is, you have the points as, let me just point it. So these are the points. C is 110, B is given as 101, C was of course 110. So OA, OB, OC is one of the method, because the faces of a regular tetrahedron are equilateral triangle. This is one of the condition. So you can prove it that the OA, OB, OC is equal, and then you say that this is, because it is, the triangle is forming different triangles which are being formed. 1, 2, 3, 4 triangles. No, 1, 2, 3, 3 triangles. And they all are equilateral triangles. That is, the tetrahedron is a regular one. But the other point is, there are multiple ways to solve this question. You take all the A, B, AO, OB, OC. A cube is a regular one. That means what? The opposite sides are exactly similar, or they are congruent, or they are equal. This is how the cube forms. So you have to imagine it in a 3D form. 3D form. So better is to find out all the sides, whichever is possible, and then equate it. And they will all be equal. Next question is, show that the points 3, 2, 2, minus 1, 4, 2, 0, 5, 6, 2, 1, 2 lie on a sphere whose center is 1, 3, 4. Find also its radius. So what do we do here? See, center is given. Center is given 1, 3, 4. So 1, 2, 3, 4. These points can be anywhere. So all these points lie on this sphere. So how to do this? If this is a sphere, you have to imagine it in 3D. So the distance from the center of these all points will be equal. And that is equal to the radius. So we have this 3, 2, 2. Most of the people, they ask me, why are you not writing the question? Basically, R.D. Sharma is going to sue me because he has a book, and that is what he sells. I cannot put the questions here. It will be, copyright issue. So these points, all these points I am writing, four points. And the only thing is, by the distance formula, you have to find the distance of all these points from the center. And that will be equal to the radius. I am trying to suggest, if center is, say, P, try to find out PA. This AP, you know how to find out the distance formula, then PB, then PC, then PD. The distance formula you have to apply. Now you will see all the values are going to come equal. If the point is not on the sphere, that is not going to come as a radius. But all the distances from the center are same, 3, 3, 3, 3. So this is the radius, and radius is 3. Now the question number, this one is 15. 15 is the question. Find the coordinates of the point which is equidistant from the 4 points. So we have to take a point which is equidistant from 4 different points, and that is on the 3D. So the way I am going to tell you, and the question is quite strategically being made. I'll tell you how. First, this is the point. Let us take it as P, X, Y, Z. X, Y, Z is the point. Now it is equidistant from A, B, C. O, A, B, C. So O is the first point. This is A point. Then you have B point. And then you have C point. O, A, B, C. O, what is the O point? No, first is 0, 0, 0. So let me make it as 0, 0, 0. O point. And now you see, one is the origin. The other one has only X coordinate. 2, 0, 0. The third one is only having Y coordinate. 0, 3, 0. Then the fourth one is only having the Z coordinate. 0, 0, 8. 8 is there. So just take the distance. All these distances are same. So OP is 0, 0, 0. That is X minus 0 whole square, Y minus 0 whole square, Z minus 0 whole square. Then add, take the under root. So this is OP will be equal to under root X minus 0 whole square, that is X square, Y minus 0 Y square, Z minus 0 Z square. So OP is this. Now take the AP. Now you see here only X coordinate is there, Y and Z are 0. This will be X minus 2 whole square plus Y minus 0 whole square, and Y square it will be, and Z minus 0 whole square will be Z square. So do you get AP? This AP. Now OP and AP are equal. In fact, all the distances are equal. So just equate this. I'm just squaring it. OP square and AP square. So X square plus Y square plus Z square is equal to X minus 2 whole square plus Y square plus Z square. So let me show it to you here. Now why this question is strategically being made? You see, Y square Z square will get cancelled, and you will get the value of X directly. You got the idea? X is 1. Similarly, this point is now known. Now take PB or BP. X minus 0 whole square, Y minus 3 whole square, Z minus 0 whole square. Y is given here only. There is no X and there is no Z. Only Y is given, 3. So what we will do? X, Y, Z. Of course, OP whole square is X square, Y minus 3 whole square, Z square. Here only Y will remain. Y will come. Third one, X square, Y square plus Z square will be equal to X minus 0 whole square, Y minus 0 square, Z minus 8 whole square. So X square, Y square gets cancelled. Z will come here. Z will be 4. So X is 1, Y is 3 by 2, and Z will come as 4. So this is how. Otherwise it will be very difficult, distance formula, equating and squaring. But because we have 0 means X coordinate, Y coordinate and Z coordinate, that's why we got the answer. Now the next question is question number 16. Now question number 16, this question is saying that find the locus of a point P which moves in such a way that 3PA equals 2PB and A and B are given. A and B are already given. Okay. So let me just, this is A point, this is B point. And then we have A and B are given. A is minus 2, 2, 3. B is 13, minus 3 and 13. Now we have a point P which is moving. Locus of that point we have to find out. So P point, locus means whatever equation is going to come. So 3PA is 2PB. Now distance PA you can find out. X minus or minus 2, x plus 2 whole square, y minus 2 whole square, z minus 3 whole square under root. This is the distance of AP. Now how about BP or PB? Distance will be x minus 13 whole square, y minus of minus 3, y plus 3 whole square and z minus 13 whole square. Okay. Now just multiply first with 3, multiply second with 2 and equate it because it is given in the question. Just square it and just rearrange. You know how to do this. We have already done this quite a time now. So here an equation will come finally. And this final equation is the locus of that point which P moves such that 3PA equals 2PB. 3PA equals 2PB. So distance only thing is what you have to do here. Now the next question is question number 17. Now important is this is NCERT question, and whichever question which are coming, we have already done that. NCERT questions. So find the locus of P if PA square plus PB square equals 2K square, where A and B are the points 3, 4, 5 and minus 1, 3 and minus 7. So here we have a point A which is this one. B point is a minus 1, 3 and minus 7. So don't worry about these points. Just worry about the concept because this question will come again and again. There is a point P which moves such that the distance of this point P from A and P from B have a relationship, and this relationship is given. PA square plus PB square equals 2K square. So just assume P to be x, y, z. Now take the distance x minus 3 whole square, y minus 4 whole square, z minus 5 whole square. This is your under root of, and we already have a square, PA square. Now put PB. PB is what? X plus 1 whole square, y minus 3 whole square, z plus 7 whole square. So these two distances with a square, that is without square root, you have to put in here, and then this equate it with 2K square. Now you see that, as I said, under root square root will not be there. You just need to rearrange. This will be the locus. I hope you'll be doing this algebraic rearrangements. Question number 18. Show that the points. Now this is not an NCERT question, but after this all the questions are from NCERT. Show that the points ABC, BCA and CAB are the vertices of an equilateral triangle. Equilateral triangle. So in R.D. Sharma, most of the question NCERT, already the question are being given to us. So people are asking me, why do we do R.D. Sharma? Why can't we do NCERT? If you do R.D. Sharma, you don't need to do NCERT, I guess. And R.S. Agarwal also you don't need to do. This is, I guess, enough questions we have. R.D. Sharma is not paying me anything. I'm just saying that I have done this book, it's good. So you have ABC, BCA and CAB. So these are the points of, or you can say the vertices of equilateral triangle. You just have to find out the distances, that is the edge length, triangle side length. You know the distance formula? You know how to do this? So you have this one, BCA and ABC. So B minus C whole square, AC minus B whole square, A minus C whole square, add them, take the under root, take the square root. Similarly, for other two edges, same thing you have to do. So when you do this, you'll see after the rearrangement, you'll see that all the sides are equal. That is the result which is coming for these three sides or edges are equal, same. So when the three sides are equal, you can clearly say that this is an equilateral triangle. Equilateral triangle, right? Now question number 19. This is again NCERT question. CBSE, NCERT, all, they will find this in their textbook. Are the points, 3 points are given, are the vertices of a right angled triangle. Right angled triangle. Whenever right angled triangle means one angle is 90 degree, you can apply the Pythagoras theorem. So when we have these 3 points, you can arrange them in any way. I don't know how to put it, but you just start with any vertices. It doesn't matter, because ultimately we just square them, and we'll see that if you add two of them, it should come as the third. So for example, this is the point we have taken. So we'll find AB, we'll find BC, we'll do AB square, we'll do BC square, we'll add them. If it comes equals to AC square, then this is a right angle triangle. That is AB square plus BC square. And if it comes equal to AC square, that is the right angle triangle. Okay. Or no, only this shouldn't be done. Other pairs also you have to check. AB square plus AC square may be BC square, and BC square AC square may be AB square. So all the possibilities we need to check. So we have 3 points, A, B and C. These points, just 10 minus 3 whole square, AB I am finding. 20 minus 6 whole square, 30 minus 9 whole square under root. 7 under root 14 will come. Now BC, 25 minus 10 whole square, minus 41 minus 40 whole square, 5 minus 30 whole square under root. So you'll get under root 4571. Third thing, find out CA. It is 3 minus 25 whole square, 6 plus 41 whole square, and 9 minus 5 whole square under root. So you'll get 3 under root 301. So these are the 3 points you are getting, 3 edges you are getting. Now just square them and add 2 of them. So if you see AB square plus BC square, it's not going to come equal to 527. The trick is that always see the highest one, biggest one, and take the 2 smaller one and square it and add. This is the only thing you do. Rather than, as I told you, pairwise adding, don't do this. Take the highest one, square it, take the lower 2 and square them and add it. If they are not equal, it's not a right angle triangle. If it is equal, it is a right angle triangle. Here it's not a vertex of a right angle triangle. This is not a vertices. Okay. Let me tell you again. In AB, BC, AC, take the longest side, square it. Take the other 2, square it, add them. If it comes to the longest side square, then it is a right angle triangle, otherwise it is not. Next is question number 20, and there are 3 parts here. 3 parts. All these 3 parts are from NCERT. And these all questions we have done already. How have we done? See, isosceles triangle we know. Right angle triangle we know. Vertices of a parallelogram we know. How to do this? We have already done that question. But let me give you an idea also here. So we have verified these 3 points are given are the vertices of an isosceles triangle. Isosceles triangle. Isosceles simply means 2 sides equal. Any triangle, if 2 sides are equal, that will be an isosceles triangle. So we'll take AB, AC, BC. Take the length of the side. If 2 sides are equal, that is an isosceles triangle. So simply you have to take the distances. Take the distance formula, find out the distance, that is the edge, length of the edge. So if you see AB, BC, CA in this particular triangle, you will see that AB and BC are equal. Third is not equal, which is this one, 6. But if you see that in the second part, the points are exactly same, almost same actually. So 0, 7, 10, 1, minus 1, 6, 6 and minus 4, 6, 9, 6. So AB square plus BC square, if it is equal to AC square, again I said, find out the triangle side, take the biggest one, square it, take the other 2 smaller sides, square it, add them. If they are equal, that is going to be a right angle triangle. So 6, AB, BC, AC, if you find out AB and BC will be 3 root 2 and the AC will be 6. 6 is higher than 3 root 2 and 3 root 2. So take the 6 square and take the addition of square of the other 2, that is 3 root 2 whole square, 3 root 2 whole square, and 3 root 2 is 18, 18 plus 18 is 18, 36. So it becomes equal. AC square equals AB square plus BC square. So that means this is indeed a right angle triangle. Now coming to parallelogram. So in a parallelogram, you just have to prove that the opposite sides are equal. Opposite sides are parallel and equal. So parallel will not be possible here. That is also possible because we can find out the slope and etc. But right now, we just prove that the opposite side length are equal. Same thing we are going to do here. We are going to find out AB, BC, CD and DA in the order fashion, and AB and CD, if you see, they'll come as 6. Both are 6. BC and DA, they are going to be under root 43. That is, they are also equal. So the opposite sides are equal. That is, it's indeed a parallelogram. This is question number 21. This is again NCERT question. Find the locus of a point which are equidistant from the point 1, 2, 3 and 3, 2, minus 1. So you have 1, 2, 3. You have 3, 2, minus 1. Now you have to find out any point P which is moving such that it is equidistant. See, this 21, 24 question, all these few questions we have done, they are exactly same. So this x, y, z we take as P point, take the distance of this point P from A, this is the distance. Take the distance of this point P from B, again this is a distance. Now just equate them, and just when you equate them, take the square, you will get, and open this x minus 1 whole square, that is a minus b whole square, a plus b whole square formula you have to use, and rearrange x minus 2z equals 0 will come. Next one is 22nd. Find the locus of the point, the sum of whose distances from the point 4, 0, 0 and minus 4, 0, 0 is equal to 10. Now they have made the question easy because two of the coordinates are 0. So we have A and B. So say one point is A and this is B. So just take the distance of any arbitrary point P. We'll take it as say XYZ. This is XYZ distance from A, that is PP. I'm taking it as XYZ. So PA distance and PB distance, XYZ distance from minus 4, 0, 0 is equal to 10. So PA distance, XYZ you take. So x minus 4 whole square, y minus 0 whole square, z minus 0 whole square. It is PA. PB will be x plus 4, 0 and y minus 0 and z minus 0. And just add them and equate it to 10. So this is the equation you have to make. And finally, you just have to rearrange. And how to rearrange? The best thing is to take PA plus PB. Now take this any PB or PB, anyone you can take on the right hand side. It doesn't matter. You can take any of this. So take on the right hand side and then just square them. Left one will only have root removed. Right hand side it will be a minus b whole square. A minus b whole square. So you have a square, you just use a minus b whole square formula, and then you see that once you open it, one more root will be there. So you have to take all the content which are not under the root on the left hand side and just keep the root term on the right hand side. So whatever possibility of simplification is there, simplify it and keep the under root on the right hand side, and then you square it, because ultimately you have to get rid of the under root, square root. So now you square it. As I said, you can just do the simplification, and the rearrangement will give you this equation, that is the final equation. This is question number 23. Showed that the points A, B, C and D are the vertices of a parallelogram ABCD, but not a rectangle. Not a rectangle. Parallelogram we have already seen. Take the opposite side. Try to prove that opposite sides are equal. That will be surely a parallelogram. AB equals CD or DC, and AD equals the other side, opposite to it. So AB and CD, this question you have already done, so they will be 6, and BC and D already we have computed, so it will be under root 43. So opposite sides are equal and opposite pairs are equal, but not a rectangle. For that you have to find out the diagonals. So you already have point A and C. You can find out the distance AC. You can find the length dB also, because D and B are also known to us. So if it would have been rectangle, the diagonals, see, it's not a rectangle because the diagonals are not equal. In parallelogram, difference is only this, so the diagonals will not come equal. This is question number 24, and this also we have done. As I said, 21 question is exactly like this. Find the equation of a set of points P such that the distance from the points A and B are equal. So I hope you know how to do this. This question is coming again and again. Maybe it's important, I don't know, but it's been coming again and again in NCERT, in R.D. Sharma, in your example R.D. Sharma, in your NCERT example. So you have a point A, which is 3, 4 and minus 5. The point B is minus 2, 1 and 4. You have this point P, and you have to take a distance of PA and PB. Just take the distance, equate them. So x minus 3 whole square, y minus 4 whole square, z plus 5 whole square, equated to x plus 2 whole square, y minus 1 whole square, z minus 4 whole square. It is under root, square them and just rearrange, you'll get this equation. This is the required equation. Now most of the students are saying, why are you not doing it properly one by one? You know, one question it takes around 6 to 8 minutes. Some questions may take 10 minutes. So if I do this 24 questions, you can assume that 24 into 10, see 24 into 240 and divided by 60. So that many hours, around 3 to 4 hours it will take to solve one exercise, and that will I don't want you to spend so much of time. You just need to know the concepts, okay? Otherwise the pen pencil, you know how to solve all these concepts, you need to know, okay? So I'll be taking the other exercise in the next discussion. Thank you so much. Take care of yourself.